In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are partner, a family. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into validation in the world by large. Thank you very much for your precious time. Today, I'm going to discuss my lecture number 21 on Center of Excellence, SIL Study Guidelines, Safety Integrity Level, Section 5. Okay, before my lecture, I used to read a Quranic verse. Kala Rabbi Shrahli Sadri wa Yassarli Amri Wahlal Uqdatam min lisani Yafqahu Qawli Allahumma Rabbi Zidni Ilma. O my Lord, open my chest and ease my task for me, and loose or not from my tongue, that they may understand my saying. Allahumma Rabbi Zidni Ilma. Allah, advance me in my knowledge. Center of Excellence, lecture number 21, SIL Study Guidelines, section 5. Okay, purpose of Center of Excellence, as we have discussed earlier, the primary theme of this lectures, where we are now in the process industry, where we want to be, and what to do and how to do. These are the 4 pillars in order to climb upon Center of Excellence paradigm. Okay. Center for Excellence governing pathway delivering on commitment, differentiated performance, enabling profit optimization of process. Okay. We have already discussed hazard and operability management system, hazards identifications, and today we are still discussing a safety integrity level, that is a SIL assessment, section number 3. We are here on section number 3. Key takeaway points from SIL study guidelines. First, the key takeaway is a risk graph for personal safety we are going to discuss today. And second is the risk graph for environment and risk graph for economic loss. The first is the risk graph for personal safety. SIL study guidelines. We have already discussed the abbreviations, the references, the team structures, responsibility planning. We are still here discussing risk graph methods and study for the calibrated risk graph method. Next, we will discuss SIL LOPA methods, recording, reporting, SIL verifications, reporting and safety requirement specification, SIL validation, and appendices on later stage. SIL introductions. Safety integrity level SIL studies an analysis which aims at the determination of the appropriate reliability required from the elements of the safety instrumented function, that is called SIF, identified to prepare safety studies, for example, hazard and hazard, etc. The approach of this guideline is to remove the uncertainty regarding the safety integrity, cost effectiveness, and availability requirement, reducing over the under engineering in a traceable manner. SIL study is a method to record all the SIF for a project development and document operating strategy. SIL study shall be conducted during FEED phase and EPSC phase in accordance with the engineering health safety plan or as required by the outcome of the safety studies of a project. SIL management is based on the amount of risk reduction that is necessary to mitigate the risk associated with the process to a tolerable level. All of the safety instrumented system SIS design, operations, and maintenance choices must then be verified against the SIL assigned data. Scope. The guideline details the structure, responsibility, and techniques of the safety integrity level study using calibrated risk graph, which I'm going to discuss in my next couple of slides, and LOPA methodology, calibrated risk graph methodology shall be primarily followed by SIL study. However, the SIL level assigned with 3 and above are using risk graph method shall be further verified by LUPA methods. LUPA methods can also be used when the SIL assessment team are using risk graph methods to unable to reach the consequences agreement on the target SIL levels. The guidance also details the requirement for the safety requirement specification, a SIL verification and SIL validation for a project. Okay, SIL application. SIL study of the project shall cover all safety instrumented system SIS in a process, a vendor package system, utility system, and fire and gas systems associated with the ESD system where there is a potential of a hazard to human safety, environment, or asset production loss. Okay, then the next is the policy. Okay, SIL policy. All oil and gas companies are committed to protect the health and safety of its employees and other that may be affected by the activities and to give proper regard to the conservation of environment. Oil and gas companies' policy is to conduct its activities such that it strives toward an incident-free, secure, safe, and healthy workplace. Safety studies and reviews shall be performed during the course of project or modifications to an existing facilities. This is to identify, qualify, quantify, and to establish that design safety measures shall provide adequate protections and mitigate any risk involved with the proposed project development or its modification. Okay, references, standards, and code. We have already discussed in my lecture. IEC 61508 and IEC 61511. Causes demand scenario, consequence of failure demand, independent safeguard, SIL assessment, consequence parameter S, E, and F. We have already discussed in my lecture number 1, 2, 3, and 4 on SIL study guidelines. Okay, exposure times. So the F1 and F2, these are parameters we are going to discuss in my risk graph. Okay, what is basically F1, F2? Rare to more often exposure in the hazard zone, normally unmanned operations of relevant part of the plant, occupancy less than 10%. F2, frequent to permanent exposure in the hazard zone, a relevant part of plant is attended locally on a regard basis every shift or during the specific time of the demand, startup or shutdown of a relevant part of the plant is located near continuously occupied road. Okay, then P1 and P2, that is the probability of avoiding the hazards parameters, that people under certain conditions, some warning available operator is capable of getting away from the hazards and the mitigated by others measures, almost impossible, no warning available, operator may not be aware of the hazards, may not be able to get away with sufficiently and quickly. Okay, W1, W2, and W3. These are parameters F1, F2, P1, P2, W1, W2, W3. We are going to discuss in my graph. Very slight probability that the unwanted occurrences shall happen, and only a few unwanted occurrences are likely once in every 30 to 100 years. A slight probability that the unwanted occurrences will happen, and a few unwanted occurrences likely more than once in every 3 to 30 years. W3, relatively high probability that the unwanted occurrences will happen, and frequently unwanted occurrences likely more than once in every 100 years. Okay, S1, S2, S3, S4, S1, CA, CB, C3, and CD. Minor injury or health effects, that is a personal safety. Minor injury or health effect, that is the second, CA, CB, CC, and CD. So the single fatality or permanent and disability, and now CD is multiple fatalities. Okay, personal safety risk graph. Okay, it started from here, the starting point for the reduction of estimations here. Okay, C stand for here, C stand for consequences parameter, F exposure or time parameter, F here. and a P, probability of avoiding the hazards events, and W here uh, in the absence of the SIL of under considerations. Okay, C, F, P, and W. Okay, now we can see here the CA, CB, CC, and CD. What it explain here, the CA, minor injury or health effects, CB, major injury or health effects, and CC, single fatality or permanent or total disability, and CD, multiple fatality. Okay, F is a exposure or time parameter, and P, probability of avoiding the hazards event. Okay, now if we can see here, so on this side, so W1, W2, W3, what it basically demonstrates, W1, W2, and W3. Okay, W basically demand rate parameters, likelihood of the unwanted occurrences, W1, W2, W3. What is basically W1 here? A very slight probability that the unwanted occurrences will happen, and only a few unwanted occurrences are likely once in every 30 to 100 years. Okay, W2. So W2, a slight probability that the unwanted occurrences will happen, and a few unwanted occurrences are likely or happen in once in every 3 to 30 years. And W3, a relatively high probability that the unwanted occurrences will happen, and frequently unwanted occurrences likely more than once in every 1 to 3 years. Okay. Now, if we can see here, see A, 1, 2, 3, 4, and B. Then next W2 is dotted A, 1, 2, 3, and 4. Here W1, first dotted, second dotted, A, 1, 2, 3. Okay. If we can see here, the dotted mean no safety requirement here. Here is no safety is required. Okay, no safety required over here. Okay. The second is A stand for no special safety requirement. No special safety requirement. Safety needed but no special requirement. And B, a single SIF is not sufficient. That B here, single SIF is not sufficient. 1, 2, 3, 4 safety integrity level. So this is over here the level 1, level 2, level 3, and level 4. Here level 1, level 2, level 3, level 4, 1, 2, 3, and 4. That is how it's integrated to each other. Okay, that is a personal safety risk graph. Okay, now next we are going to discuss the risk graph involvement. Okay, first we will discuss involvement consequence parameter, then we'll link with the graph, how the graph can be demonstrated. First is a even CA. The minor effect combination damage a sufficient large to impact the environment. Single exceeding of a status of the prescribed limit, a single complaint, or no permanent effect on the environment. That is the first CA and even. E2 CB, localized effect, limited loss of discharge of unknown toxicity, repeated exceeding of status or prescribed limit and beyond fence or neighborhood. Next is the CC, major effect, severe environment damage. The company is required to take extensive measures to restore the contaminated environment to its original state, extended exceeding of the stage of the prescribed limit. CD, E4, massive effect, persistent severe environment damage or severe nuisance extended over a large area in terms of commercial or recreational use or nature's conservancy, a major economic loss for the company, constant high exceeding of the stages or prescribed limit. Okay, now from the next slide we will link with how the graph demonstrate these factors. Okay, so if we can see here the environment loss in risk graph, this is my starting point here, and this is a CA. CB, CC, and CD as we discussed. And C for consequences, a parameter. F for F over here not used, and number a P probability of avoiding the hazards event, and W in the absence of the SEF under consultations. So similarly here W1, W2, W3, and if we can see here, this is the dotted line mean safety is not required. A stand for no special safety requirement. B, a single SAF is not sufficient. 1, 2, 3 mean safety integrity level. Level 1, level 2, level 3, level 4, level 1, level 2, level 3, 4, 1, 2, and 3. And B stand for B, a single SAF is not sufficient. Okay, that is environment loss risk graph presented over here. Okay. Okay, risk graph for economic loss. Before starting, we need to give some brief descriptions. What are the parameter involvement, economic asset consequences on risk graph for economic loss? The first is a C1, CB, CC, and CD. Okay, first is a CA. What is CA? Minor damage, brief disruption to operation with estimated cost less than $100,000. CB, almost 1 million. Localized damage, partially shut down of operation, can be restarted but with estimated cost up to $1 million. CC, the major damage, partial loss of operation, 2 weeks shutdown with estimated cost up to $10 million. And last CD, the massive damage, substantial or the total loss of operation with estimated cost in excess of $10 million. Okay, now we're going to discuss risk graph. Okay, economic loss, risk graph for economic loss. We can see here the C for the consequences here, F not mentioned here, P probability of avoiding the hazards events, and W mean in absence of the SEF under consideration. Okay. These parameters are discussed here, W1, W2, W3. Okay, so if we can see here, the dotted line has a separate meaning, and this is integrity 1, 2, 3, 4, and B has different meanings. The dotted line means no safety requirement. A stands for no special safety requirement. A B, a single SEF is not sufficient. 1, 2, 3 for the safety integrity level. Okay. So we have already discussed W1, W2, and W3 in my last slide. Okay, this is my last slide, safety integrity level, demand mode of operations. So if we can see here, the first here from bottom to top, we'll start from 1 to 4. The first level 1. So level demonstrate here, it's a greater than 10 or minus 2 to 10 or minus 1. Level 2 here, so that is greater than, so 10 minus 3 to minus 2 over here. And number 3 SIL level is 10 minus 4 to 10 minus 3 and 5 to 4. So that is how it demonstrated in W1, W2, and W3 the occurrences of the safety integrity level. Okay, so now we are going to conclude today's lecture here. Today, conclusion, we have discussed the first risk graph personal safety, risk graph environment loss, risk graph economic loss, and SIL level 1, level 2, level 3, and 4. So, okay, my next lecture will be SIL study with LUPA method. Thank you very much. Okay, we have references here. The first is Qatar Petroleum, Doha, Qatar, Oil and Gas Development Corporation Limited, Pakistan, World Energy Outlook 2013, US Geological Survey, US Department of Energy, Schlumberger's Oil Field, International Energy Agency, IEA, Wikipedia, Oklahoma State Oil Marshall Commission's Pumpers Manual, State Oil Fact Sheets, Norfolk Standard, The Story of the Oil in Pennsylvania, A Liquid Gas Encyclopedia, Natural Gas from the Well to Burner Tip. Okay, Please do not hesitate to send me your feedback and comments at t.masood.dr@path.edu. Please send me your input. You may send me through WhatsApp. I have also provided my WhatsApp number. Thank you very much for your precious time. Thank you and stay blessed.